Hello, welcome back to my channel. I'm here yourself. So we're about to guide you again with the circles. So I think you are keeping a track of this channel. So far we have already been able to solve many questions. This will be the 7th question. So I hope all of you are staying at home and then studying. That's why I'm here to help you with these videos. Anyway, let's go straight to the point. The question number 7 here, class 10. NCERT textbooks, exercise 10.2, question number 7, circles. Two concentric circles are of radii 5 cm and 3 cm. Here, what do you mean by concentric circles? Concentric circles are circles which share the same center but can be different radius. So let me just draw the concentric circles. Maybe I'll just draw a bigger circle with a common center, and then I'll draw a smaller circle. So both of them, of course, they will be sharing the same center here. Of course, the circle looks very odd, but please don't mind my figure here. Then, so of course, are of radii 5 and 3 cm. That we will discuss later on. Then, okay, so I think that looks a little bit better. Okay, slightly better, right? Okay, then find the length of the chord of the larger circle which touches the smaller circle. So maybe a chord which touches the smaller circle. Maybe let's this be the chord. I hope you have your pen and paper along with you, so please make sure that you draw along with me. So, let's just assume, so let the common center be O. And let's name this chord as AB. Let AB be the chord of the larger circle touching the smaller. I think you have written down the question. Touching the smaller circle at P. Next up, we join OP. And let's just join OA. So we join OP and OA. Done? You can pause the video and write on the notes or rub it off. So, OP of course becomes the radius of the smaller circle, OA becomes the radius of the bigger circle. So to find out AP, isn't it? So now this one we know is 90 degrees, since we're already doing now I think the 4th video on this circle, so I guess you already know the theorems. OP is going to be perpendicular to AB because tangent perpendicular to radius through the point of contact. Right. So now what will happen is, in triangle OAP, so this is 5, this is 3. Let me first find out this. I'll discuss more about how do we find out. Our job is to find out AP, but we'll discuss about that. So in triangle OAP, what happens is OP square plus AP square will be equal to OA square. So OP 3. AP square is equal to 5 square, 9 plus AP square equal to 25, AP square equal to 25 minus 9. Again we're finding out length, so for square we are going to be ignoring the negative values, remember? 16, so that's going to be like 4 centimeters. So AP is 4 centimeter. So now what happens here is, see, the chord of the bigger circle AB actually is touching the smaller circle at the point P. That means like AB is also like a tangent, isn't it? Right. And another theorem that we have studied, that is in class 9, that is a perpendicular drawn from a center to a chord bisects the chord. We studied that, isn't it? The perpendicular drawn from the center of a circle to a chord bisects the chord. Bisects the chord means cuts it into equal halves. So AP will be equal to BP. So since AP is 4, BP is also 4. Then what should happen? In that case, AB is going to be AP plus BP. So that's going to be 4 centimeter plus 4 centimeter. So that's going to be 8 centimeter. Got that? So that's going to be your solution. Okay? Alright. Let's move to the next question quickly. So you can just note down the question. In the meantime, I'll try to draw the figure. Don't mind the figure again, because here in this question what matters is the circle and the properties only. So not necessary that it has to be perfect. I tried. It's going like that. Okay, I think that's much better. Slightly better. Okay, chalo. The points of contact. Question. You can write on the question. I'll discuss about the question. I'll just finish the figure once. A, B, C, D. A, B, C, D. Pictures. So in the question, what happens is question number 8. The quadrilateral. A, B, C, D. The quadrilateral A, B, C, D is drawn to circumscribe the circle. Is drawn to circumscribe a circle. The quadrilateral is drawn to circumscribe a circle. Prove that what was given to prove AB plus CD is equal to AB plus BC. Chalo, prove. What do you have to prove? AB plus CD is equal to BC plus AD. Okay, not a very difficult question, very simple. One simple concept, one small concept that you will require, that is, see. First write down, okay, tangents drawn from an external point to a circle are equal in length. You remember the first activity that we did? In that activity we have done this activity also, isn't it? So I think this is the first time that we are using this activity. That is, a tangent drawn from an external point to a circle are equal in length. Now if you look at the figure carefully, what happens is, see, from the point A, this AP AP and AS, do they look like tangents to you? Yes, they look like tangents. They are tangents because it's touching at only one point, isn't it? That means AP can be written as AS. Got that? Similarly, from the point P, BP and BQ are two tangents. So then BP is also equal to BQ. Right. Similarly, CQ and CR are two tangents. That is, CQ and CR are also two tangents. And finally, DR and DS are also two tangents. So DR and DS are also two tangents. So we can just mark this as equations 1, 2, 3 and 4. Got that? Now did you notice something here when I was writing these equations? Because see, I arranged and wrote so that I do not get extra problems later on. That is, in the proof, I had to prove that AB plus CD, that means this is one group, is equal to DS and BC, another group. So when I wrote AB and BP along the same side, because see, I wrote here, no, AP is equal to AS. I could have easily written for the second one, BP, BQ, I could have easily written BQ is equal to BP. No, just reverse. I could have written BQ is equal to BP. It will be correct, but I did not write that. I just wrote BP is equal to BQ because AP and BP, you see that they form one group. You see BQ and CQ, one group. CR and DR, one group. DS and AS, one group. So that's why you see I wrote in that particular order so that when I add the four equations, everything will be very well arranged for me. Because mathematics, it's up to us to make our problems difficult or easy. I'm going to rub this off now. So you see, AB and BP already arranged, AB. That one, CR and DR, already CD. Here, of course, one more line to arrange. So this is already there, AB plus CD. Because now AS plus DS, that's going to be AB, plus BQ plus CQ, that's going to be what? BC. Isn't that the proof? So if you do not arrange and write, what will happen is that you will have to write maybe extra 2-3 steps because from the equations you'll have to substitute and solve. So you may end up writing extra steps for that. Okay, so just to avoid that, you can do one thing, you can arrange and write. Okay, so I think that's going to be enough for today. So if you have liked this video, please share with maximum of your friends so that they can benefit from this video. And in the next video, we will do another again, 2-3 more problems. Okay, so if you have liked this video, please hit the like button only after watching the full video. Okay, and then please do subscribe and help me reach more and more students. Thank you. Have a good day, all of you.